What is the inverse of f of x equals 1/5 x minus 2? Remember, we can write this as y equals 1/5 x minus 2. Then what we want to do is we want to switch the x and the y. We have x equals 1/5 y minus 2. Next, we want to add 2 to both sides. 2 minus 2 is 0. You're left with 1/5 y equals x plus 2. Then you want to multiply by the reciprocal, which is 5 over 1. Multiply by 5 over 1. And you have, when you apply the distributive property, you have 10 plus 5x equals 5 divided by 5 is 1. 1 times 1 is 1, so you have y equals 5x plus 10. And the way they want it is the inverse of f. X equals 5x plus 10. Number 2, we have to verify that they're both going to be inverse functions of each other. That's what it's saying. Well, the composition of functions with domain restrictions show f and g are inverse functions. So we're going to have to figure out f of g of x and check if it comes out to be x. And we have to check g of f of x and see if it comes out to x. So let's go ahead and do f of x, f of g of x. So we have f. Remember that g of x is x squared minus 7. So we're going to input x squared minus 7. So we have x squared minus 7. And then we're going to use function f as our process. Here's function f as our process. So wherever you see an x, that is the input. So in this case, the input will be x squared minus 7. That's the input. So go ahead and take a minute to see that. Remember, this is the input. This right here is the input. So now we're going to go ahead and do some algebra. Negative 7 plus 7, that's 0. We're left with x squared. And the square root of x squared is x. Okay. Now we're going to go ahead and show g of f of x. So I'm going to pause it for right now. So we're going to check g of f of x. So we have g. Now our input is f. The input is square root of x plus 7. So now our input is f. Our input is f. So now we have square root of x plus 7 squared. That's the input right there. You see that? Minus 7. When we square a square root, they cancel, so we're left with x plus 7 minus 7. That's 0, and that does show it's x. Okay? We really didn't touch upon domain restrictions, but for the purpose of reviewing, I just wanted you to understand how to check that they're inverse of each other. 4 and 7, or x is greater than or equal, or x is less than or equal to 7, which is not a representation. So what we're going to do first is we are going to use the function, the original function, the original equation, and we're going to find its inverse. So we have f of x equals 1/2 x minus 3. So we're going to rewrite it as y equals 1/2 x minus 3. To find the inverse, remember that you have to switch the y and the x. So you have x equals 1/2 y minus 3. So now the next step is to solve for y, so we add 3 to both sides. So we have x plus 3 equals 1/2 y. Then we find the reciprocal of 1 over 2, which is 2 over 1. This becomes 1. 1 divided by 1 is 1. So you have y equals 2x times 2 times 3 gives you 6. So to write it using inverse notation, the inverse of f is equal to 2x plus 6. So we automatically know that this is a correct showing of I have to make a table. And we knew that f of x, the domain was between 4 and 7. So if x is 4, and I'm going to input this into the original equation, we have 1/2 times 4 minus 3, which gives you 1/2 of 4 is 2. 2 minus 3 is -1. So the inverse, we have 4, -1, so the inverse should be -1, 4. So that checks. See, I decided to make a table so I could see the inverse of the relation, or the inverse function, the table, to verify. We have 5, so we have 1/2 times 5 minus 3. So 1/2 of 5 is 2.5, 2.5 minus 3 is -1/2. So the inverse would be -1/2 5, so that checks. The next one is 1/2 times 6 minus 3. 1/2 of 6 is 3 minus 3 is 0. So it should be, the inverse should be 0, 6, so that checks. And then the last one is 1/2 times 7 minus 3. 1/2 times 7 is 3.5 minus 3 is 1/2. So the inverse should be 1/2 7. So what did I make? Why did I make a table? I first wanted to figure out what was my original table for f of x based on this interval from 4 to 7. So now what I'm going to do is I'm going to make a table, an inverse table. And how do I make an inverse table? I just have to switch the x and the y. So I have -1, 4, which checked there. -1/2, 5, 0, 6, 1/2, 7. So C is also correct. So now we got to check D. D, we're going to graph the inverse. We have to graph the inverse. We have -1, -1, 4, -1/2, 5, 0, 6, 1/2, 7, so that does check. So the incorrect answer is A. What we're doing here is we're solving absolute value equations. So we have the absolute value of 3x plus 1 equals 8. Remember, if we're multiplying times the absolute value, or we're adding plus the absolute value, we got to do something first prior to separating into two different possibilities. Now that we have the absolute value by itself on the left hand side, we have two answers that could be possibly the answer. So you have 3x plus 1 equals 8. 3x plus 1 equals -8. You're going to go ahead and subtract 1. So you have 3x equals 8 minus 1 is 7. Divide by 3. So x equals 7 over 3. Now the next possibility is you subtract negative 1 from both sides. So you have 3x equals negative 9. Divide by 3. So x equals negative 3. Now that's one answer that could be possibly it, and here's the other answer. So now we need to check. Remember the extraneous answers? So you have absolute value of 3 times, this is going to go over here. So you have 7 over 3 plus 1. These 3 cancel, so 7 plus 1 gives you the absolute value of 8. So it's 8. So that does check. So we know the answer is definitely 7/3, so C is not correct. So now the next one is negative 3, or let me take that back. 3 times negative 3 plus 1. Negative 3 times negative 3 is negative 9 plus 1 is negative 8. And we know that the absolute value of negative 8 is 8, so that is correct. So your answer is negative 3 and 7/3. So your answer is B. Number 5, we're solving this absolute value equation. We have 3, and then we have the absolute value of x minus 7 minus 2 is equal to 4. Remember that we have to first add 2 to both sides. So we have 3 times the absolute value of x minus 7 is equal to 6, since this is 0. We divide by 3. So we have the absolute value of x minus 7 is equal to 2. And that's where we have to get to. Now we can go ahead and come up with our 2 solutions. So we have x minus 7 is equal to 2. X minus 7 is equal to negative 2. You add 7 to both sides. So x equals 9. You add 7 to both sides. So you have x equals 5. We have to check for those extraneous answers. So you have 3 times 9 minus 7 minus 2. And we know that 9 minus 7 is 2. 3 times the absolute value of 2 minus 2. 3 times 2, well, the absolute value of 2 is 2. 3 times 2 is 2. 6 minus 2 is 4, so that does check. So we have 3 times the absolute value of 5 minus 7 minus 2. 3 times the absolute value of negative 2 minus 2. And we know that the absolute value of negative 2 is 2. 3 times 2 minus 2 does give you 4, so that's check. So it's going to be 9 and 5, or 5 and 9. Number 6, we're solving an absolute value inequality. So we have the absolute value of 4x plus 1 is less than 5. So we have 4x plus 1 less than 5. So it's going to be and 4x plus 1 is greater than negative 5. So we're going to subtract 1 from both sides. Since that's 0, we're left with 4x is less than 4. Divide by 4, so we have x is less than 1. So the first part of the solution is x is less than 1. Then we're going to go ahead and subtract 1 from both sides. So we have 4x is greater than negative 6 divided by 4. So x is greater than, this is going to simplify. Since we both are divisible by 2, we have negative 3 over 2. So x is greater than negative 3 over 2, but is less than 1. So your answer is B. So you have 1, you have 0, you have negative 3 over 2, open circle, open circle. We know that x is less than 1, so it goes in this direction. X is greater than negative 3 over 2 goes in the other direction. So the solution will be those values that are between negative 3/2 and 1. That's a solution. I decided to give you some more examples on composition. I'm going to go ahead and do number 7. And so what we're trying to find is f. We're trying to find f of g of x. And we're also trying to find g of f of x, okay? We're not checking if they're inverse, we're just doing the composition. So we have f, and so now the input is g of x, and here is g of x. So the input is x squared plus 1. So we're going to use f as our process. We're going to use f as our process. So what do we have? We have 3 parentheses plus 5. So what goes into the parentheses? It will be x squared plus 1. So you do the distributive property, so you have 3x squared plus 3 plus 5, which gives you 3x squared plus 8. And that is a composition. So now we're going to go ahead and do the opposite. And we have f of x now as the input. So we have g, and the input for f is 3x plus 5. So now the input has to be squared, and then you have to add 1. So you have 3x plus 5 to the second power plus 1. So I'm going to go ahead and do it on the side. 3x plus 5 times 3x plus 5, and I'm going to go ahead and do the FOIL method. 9x squared, 3x times 5 is 15x. 5 times 3x is 15x, and then 5 times 5 is 25. So what do you have? You have 9x squared plus 30x plus 25 plus 1. So you end up having 26. So it's probably easier just for me to change it here to 26. And that is a composition. So now what we're going to do is we're going to do f of g of x for number 8, and we're also going to do g of f of x. Once again, I'm going to color coordinate. So we know that g of x is going to be, in this case, green here. That is your input. And then your input for your other composition is f of x. So just keep that straight. And now we'll go ahead and do some algebra. So we have f, and then the input is x plus 4. So we're going to go ahead and use f, and we have negative 2. And then you have the input squared. So what goes in there is x plus 4. So I'm going to do this on the side. X plus 4 squared. So it's x plus 4 times x plus 4. X times x is x squared. X times 4 is 4x. 4 times x is 4x. And then 4 times 4 is 16. So what you have in here is negative 2 parentheses x squared, and then 4x plus 4x gives you 8x plus 16. You still have to distribute the negative 2. Negative 2x squared minus 16x minus 32. Okay? Now we're going to do g of f of x. So we have g, and our f of x is negative 2x squared. That is our input. Just like this was our input. So just so we don't get confused, I'm going to go ahead and write it down here. G of negative 2x squared is equal to, my input is negative 2x squared. That's the input, plus 4. So what is the composition of g of f of x? negative 2x squared plus 4. Let f of x equal 5x minus 4 and g of x equals x squared minus 1. So we need to find g, and then the input is f of negative 1. So we have g of f of negative 1. So we have to evaluate f of negative 1. So we have 5 times negative 1 minus 4. 5 times negative 1 is negative 5. Minus 4 gives you negative 9. Okay, 5 times negative 1 is negative 5 minus 4 is negative 9. Now we've got to find g. This becomes the input. Negative 9 equals negative 9 squared minus 1. Negative 9 squared is 81. Minus 1 gives you 80. So we figured it out. It's 80. For the next example, we have to do f of g of 2. So you got to figure out g of 2. In this case, it's going to be the input squared minus 1. So the input is 2. 2 squared gives you 4 minus 1 gives you 3. So now this will become the input of f. So we have f, and then our input is 3. So we have 5 times 3 minus 4. 5 times 3 is 15 minus 4 gives you 11. Okay. So what you're going to do is you're going to try to figure out g of f of 0. So the first step is to find f of 0. F of 0 is 5 times the input minus 4. 5 times 0 is 0, so you're left with negative 4. That becomes the input for g. It's negative 4. So you have negative 4 squared minus 1. Negative 4 squared is 16 minus 1 is 15. So g of f of 0 is 15. Number 13, I'm going to work that out. 12, I expect you to do it on your own. 14, I'm going to try to work it out too. So we have y equals x squared plus 7. So we have to switch the x and the y. So we have x is equal to y squared plus 7. Subtract 7. So you have x minus 7 is equal to y squared. And then we want y by itself, so we're going to get the square root. So y equals the square root of x minus 7. And the way you see it, and the answer will be the inverse of f equals the square root of x minus 7. So for number 14, we have y equals 6 minus 2x over 8. We're going to switch the y and the x. So we have x is equal to 6 minus 2y over 8. Multiply both sides times 8 since we're solving for y. So we have 8x is equal to 6 minus 2y. Subtract 6 from both sides. You can't subtract these two. So you have 8x minus 6 equals negative 2y. Then divide by negative 2. So your equation will be negative 4x plus 3 equals y. And the way you're going to see the answer is the inverse of f of x equals negative 4x plus 3. Number 16, I'm going to do 16. So we have the absolute value of x plus 6. I'm going to write x plus 6 is equal to 2x. Or we have x plus 6 is equal to negative 2x. Remember, you have those two different possibilities. What I'm going to do is I'm going to subtract x. So I have 6 equals x. I'm going to subtract x from both sides. So I have 6 equals negative 3x. Divide by negative 3, and you have x equals negative 2. So now we have to check. So you have the absolute value, and then the input is 6 plus 6 equals 2 times 6. So 6 plus 6 is 12. The absolute value of 12 is 12, and 2 times 6 is 12. So it does check. Okay, the next one. We have negative 2 plus 6 equals 2 times negative 2. So we have 4 equals negative 4. That's not true. So the only solution will be 6. X equals 6. I do want to challenge you to do 15 and 17. So for number 18, we have 4x plus 1 is less than 5. 4x plus 1 is greater than negative 5. And I did that because we weren't adding or we were multiplying. So we're able to do the two possibilities. We subtract 1. So we have 4x is less than 4. Divided by 4. So x is less than 1. Subtract 1, subtract 1. So you have 4x is greater than negative 6. Divide by 4. So x is greater than negative 3 halves. And I think, I'm looking at this, I think we did this already. So it's 1, negative 3 halves, and it's greater, so it goes this way, and it's less than, it goes this way. Okay.